Hi, my name is Rick Schrader, and this is my final presentation for our materials class. I decided to do my research on a product. It was a Seagate Barracuda 160 gigabyte hard drive. During my research, I was lucky to be able to find that Seagate had already done a life cycle analysis on the hard drive, so that gave me some insight into the materials, because in their life cycle analysis, they did break out the material BOM. So since a lot of the environmental impact had already been done, we can talk about that here briefly, but I decided to focus on the social impact of the manufacture of the hard drive. If you can see over on the left-hand side in the pie chart, an interesting thing is that 43% of the environmental impact is driven by raw material extraction and pre-processing. It's a major player in almost every one of the categories that are demonstrated over on the right-hand side, ranging from climate change, ozone depletion, water depletion, ionizing radiation. Each of those, if you look on the bars, you see the blue section contributing significantly to it. So the extraction process from an environmental perspective is the part of the product life cycle that has the largest impact, at least for a hard drive, on the environment. And then what I decided to do is take a look at what are the social impacts associated with this as well. So over on the left-hand side, you can see the BOM that Seagate had on their life cycle assessment. Basically, it's broken out into the cumulative, each element's contribution to the cumulative weight of the hard drive. So you're able to take a weight of a hard drive, which is about a pound, 0.5 kilograms, and aluminum, for example, is 61% of that. So you can figure out what the weight of that is. And this is for an individual hard drive. And if you assume that millions of hard drives are made, then it gets quite significant. There are some exotics that are used in manufacture of hard drives, but manufacturing processes have made sure that they're minimized at the most because they're expensive. Some of the materials are measured down to atoms and micrometers, so microinches. So there's very little of the gold and the platinum used in the manufacture of the hard drive. Probably not as much by cost economically, but certainly by weight. I focused on 7 materials. Those are listed under the product system. Aluminum, I converted to bauxite because that's the material that you extract. Same thing with chromium. It's chromite out of South Africa. And identified those as the items that I wanted to look at, but I looked solely at the extraction process. So I did not include the rest of the product life cycle that you see down there on the bottom, design through disposal or reuse. I excluded those from the evaluation. Again, to focus on the extraction, because extraction was the largest contributor to the climate impact, and now we wanted to see if it was a contributor to social impact. Really, you know it is, but I really wanted to see what the difference was between China and the United States. So I created 4 models. One was straight Chinese, one was straight United States, assuming that both countries could source all materials domestically. Then took a step back and said, well, realistically, chromite isn't naturally sourced or domestically sourced, neither one of those. So I outsourced that to South Africa because that's where that material is found. Copper, on the other hand, is found in the United States, so I left that in the United States model, but I outsourced that to Chile in the Chinese model. That gave me the opportunity to put a little more realism in it, but I didn't want to make too many changes so that I could do kind of an apples-to-apples comparison. In order to do that, I looked at several different things. I used resources such as the Seagate website. I had to do some conversions into financial 2002 US dollars because the social hotspot database input is in 2002 US dollars. I looked at several government websites to identify, really cross-check the information that I was getting. And I used a tool called SimiPro to actually create the database. In creating the database, basically what I had to do was convert the weight of the material in the BOM to a dollar value and then deflate that to 2002 dollars. So over on the right-hand side, I had a financial input that I could put into the SimiPro model. In just those 7 materials, they added up to about 50 cents. I'm sure once you get the exotic materials in there, you may have up to $1, $1.50. But again, this is before the manufacturing process, and this is simply spot price. It hasn't been processed whatsoever. So basically what you do is you take that information, you input it so you can create that BOM of those 7 materials, and then you bump that up against the social hotspot database, which looks at those countries and the social issues associated with each of those materials and in those specific countries. And so the difference between China over on the left-hand side and the United States over on the right-hand side is significant. This is a buildup of all of the social issues, but still you can see that the bars are significantly higher over on the left-hand side. One of the things that I identified was interesting was outsourcing the chromium to South Africa, the chromite to South Africa, and the copper to Chile actually reduced the social risk for the Chinese model. Over on the right-hand side, we only had the one part that was outsourced to South Africa, so it didn't have much of an impact. But you can see these 2 bars are starkly different. I looked a little more in detail, sorry, and tried to identify what's associated with it. Labor rights and decent work. That's the biggest issue. As you can see, the bars for the green bars are significantly higher than the orange bars. So apples to apples, these guys are on different levels, but labor rights and decent work is the largest contributor. I was able to look deeper into that and find out there are categories inside that. What are the categories that are driving that disparity? Collective bargaining, toxics, and health hazards, migrant labor, and conflict areas are problems that are really driving the Chinese model and the social impact of the extraction of these materials for hard drives. And this could be the extraction of materials for other items as well. In looking at those 2, there were several things that stood out significantly. Workers in the extraction process in China are 17 times higher to have social risk issues than workers in the United States. Labor rights and decent work conditions is the most significant factor, but collective bargaining, toxics, migrant labor, and conflict areas need to be addressed. These aren't going to happen quickly, but those are the areas that need to be addressed. Within the Chinese model, and looking at the difference between the Chinese model and a couple of other countries, items in the Chinese model that stood out were migrant labor. They needed to improve the sanitation, gender equity, and forced labor. So those are items that are social impacts to the manufacturer of the hard drive. So in conclusion, one of the things that stood out, at least for me, was the huge disparity between sourcing them in China and sourcing it in the United States. If it was, kind of a little bit, I wouldn't have been as surprised, but it was a huge difference. So there's a lot of progress that needs to be made. Rectifying the social hotspots in China isn't going to happen overnight. It's going to take a while because they're prioritized behind economic development. And those 2 kind of go hand in hand. It's like the balancing scale. If you want to make things cheaper, then you need cheaper inputs. Labor is one of the inputs. So you're not going to really spend a lot of time trying to figure out how to address those social issues because there are costs associated with that. I was also surprised to find out that the outsourcing of copper to Chile and chromium to South Africa actually improved the Chinese model. So the social impact in South Africa and Chile is less than it was in China. That really surprised me. And last, in doing the research, so the Chinese are setting up a lot of extraction processes in Africa so that they have access to the resources because they're using more and more resources. And there is becoming a lot of friction between Africa and these Chinese companies in the way that they address labor in these extraction facilities. Some of it is African labor, which the African countries don't feel are being treated fairly by the Chinese. Some of them they are bringing in Chinese employees, and the African countries feel like their labor force is not being used or have issues with the way that Chinese labor is being addressed. So I hope this helps. I looked briefly at the environmental impact, but a lot of that was done with the life cycle assessment. We could see that the extraction process was the majority of the impact on it. And I wanted to take a look at the social issues associated with the extraction of the materials that actually go into the hard drives. Thank you very much.